Okay, so with this example, we're supposed to find the equations of all tangent lines to the graph of this function, f of x equal to 6 minus 3x squared, that pass through the point minus 2 minus 3. All right. So notice, first of all, that we're not actually asked to find the equation of the tangent line to this actual function at the point minus 2 minus 3, but the equations of all tangent lines to the graph of this function that happen to pass through this point. So it's a slightly more complicated question. In fact, the point minus 2 minus 3 doesn't lie on the graph of this function. So let's notice that first. So note that f at minus 2, so if we were to evaluate this function here at minus 2, let's see what we get. And I think we're not going to get minus 3. This is equal to 6 minus 3 times minus 2 squared, which is 6 minus 12, which is minus 6, and that is not equal to minus 3. So, in fact, the point minus 2 minus 3 does not lie on the graph of f. Does not actually lie on the graph of f. So we can't actually find the equation of the tangent line to f at minus 2 minus 3. And that's why in our question here, we're not actually asked to find the equation of the tangent line to f at minus 2 minus 3, but the equations of all tangent lines to the graph of this function that pass through minus 2 minus 3. Well, let's draw a picture so we see what's really being asked then. Okay, so our function here, it is, I guess I better come up again, it's f of x is equal to 6 minus 3x squared, and this is a parabola opening downwards with y-intercept 6. So let's draw that first of all. Come down again. Okay, so this is our picture here. All right, so our picture looks like this. So we have this function here. It's f of x is equal to 6, remember, minus 3x squared. So we've got a y-intercept of 6. I'm not going to try and draw this to scale. It just won't work out. So I'll draw a parabola opening downwards like this and like this. In fact, you could check. So this is y equal to 6 minus 3x squared. And that is, in fact, our f of x. And you can check, actually, if you want, and see that these x-intercepts, which is to say when 6 minus 3x squared is 0, occur when x is plus or minus root 2. We're looking at the point minus 2 minus 3. We mentioned that this actually isn't on the graph of f. The point that is on the graph of f, the point that is on the graph of f is minus 2 minus 6. So minus 2 minus 3 is sitting somewhere about here. So let's put that on. Here's our point. So our point here, it looks something like this. I'm just going to draw it out here. Minus 2 minus 3. So I'm not going to be able to manage this to scale, so I apologize for that. But let's just say that this is our point here, minus 2 minus 3. All right. And the actual point on our graph, minus 2 minus 6, Well, this is minus 2, minus 6 is, and this is a y value minus 3, minus 6 is somewhere down here. All right, so we can't talk about the tangent line to f at minus 2, minus 3, because this point doesn't actually lie on the graph of this function. But nonetheless, it may be true, and it certainly looks like it's true, that there should be at least one tangent line to y equal to f of x that passes through the point minus 2, minus 3. So let's try and draw such a tangent line on here. Make it green, I guess. All right, so it looks like there should be at least one tangent line here, maybe that passes through the point minus 2, minus 3. And in fact, there might be others. Maybe there's a tangent line that runs like this, something like that, that also passes through minus 2, minus 3. And what we want to do, according to the question, if we go back up, is we want to find the equations of all tangent lines to the graph of this function that pass through the point. All right, so I'm looking in particular then for the equation of this green line, if in fact it exists. So what will we do? Well, what we'll do is we'll notice that this is in fact going to be the tangent line to y equal to f of x at some point a. All right, so this is in fact the tangent line to y equals f of x at some point a, and what we're going to do is we're going to try to solve for this a. All right, so how are we going to do that? Well, what we'll do is we'll find the equation of this tangent line. Maybe we'll call it L sub a. We'll find the equation of this tangent line L sub a, and we'll solve for a such that minus 2, minus 3 lies on this line. All right, so we're going to find the equation of this tangent line L sub a, and we'll solve for a so that minus 2, minus 3 happens to lie on this line. Okay, well, what do we know about L sub a, this tangent line to y equals f of x at x equal to a? Well, we know in particular that it contains the point a, f of a. So it contains the point a, f of a. Let's see if I can actually write this on here. It contains the point a, f of a, and it has slope equal to the derivative of f at a. All right, so slope of the tangent line to y equals f of x at x equal to a is equal to f prime of a, the derivative of f at a. So let me just write that down in a sentence then. And here we go. So, write that here. Back to blue. All right, so L sub a, the tangent line to y equal to f of x, which in this case is, as we said already, what was it, 6 minus 3x squared. All right, so L sub a, the tangent line to y equals f of x, which is 6 minus 3x squared, at an arbitrary point x equal to a, well, we know that it contains the point a, f of a, and actually, let me write that down in more detail. A, f of a, and what's a, f of a in this case? That is a, and what's f at a? Well, f of x is 6 minus 3x squared, so f of a is 6 minus 3a squared. All right, so 6 minus 3a squared. Okay, so L sub a contains the point a, comma, 6 minus 3a squared, and has slope well, the slope of L sub a is, as we said, the derivative of f at a, which in this case is, well, if you look up here, f of x is equal to 6 minus 3x squared, so f prime of x is equal to minus 6x. So at a, the derivative is going to be minus 6a, and I'll just write in brackets, because f prime of x, the derivative of f at x is minus 6 times x. All right, so what do we have now? We have, looking at L sub a, and remember, L sub a is this tangent line to y equals f of x at x equals a. Said it contains the point a f of a, and its slope is f prime of a. In other words, it contains the point a f of a, which is a, comma 6 minus 3a squared, and its slope is minus 6a. If we have a point and we have a slope, we can give the equation of this line L sub a. So let's write down the equation of this line. So, hence, L sub a has the equation
Dad?
yeah.
I'm ready.
Okay, just a sec. Okay, and here I am back after that rude interruption. 20 minutes later. Hence, L sub a has equation, as I was saying, y minus our given y value, which is 6 minus 3a squared. So y minus 6 minus 3a squared divided by x minus our given x value, which is a, equal to the slope of our line, and the slope of our line is minus 6a, as we said. Minus 6a. Okay, so now what are we trying to do? We're trying to find all such tangent lines, L sub a, so this is L sub a. We're trying to find all such tangent lines L sub a such that the point minus 2 minus 3 lies on this line. All right, let's go up. Remember, we're trying to find all tangent lines L sub a such that the point minus 2 minus 3 lies on this line. All right, minus 2 minus 3 is going to lie on the line L sub a if and only if it satisfies this equation, the equation of the line L sub a. All right, minus 2 minus 3 lies on L sub a if and only if it satisfies its equation. So let's go down, and now we have the equation of L sub a. Here it is here. And we can say that minus 2 minus 3 lies on L sub a exactly when it satisfies this equation. So we'll solve for all values of a such that minus 2 minus 3 actually satisfies this equation. Okay, so let's write that out. So minus 2 minus 3 lies on the line L sub A if and only if it satisfies, or maybe I shouldn't write it, if and only if minus 2 minus 3 satisfies the equation for L sub A. Alright, so we'll solve for all values of A such that minus 2 minus 3 satisfies the equation of L sub A. That's what we're going to do now. Alright. Okay, so minus 2 minus 3 satisfies this equation if and only if, when we replace our y here by minus 3 and our x here by minus 2, the equation is satisfied. Alright, so let's actually continue that sentence. Minus 2 minus 3 lies on L sub A if and only if it satisfies the equation for L sub A, and that's true if and only if replacing y, as we said, by minus 3. Alright, so I just replaced the y up here by minus 3, and now I'm going to replace the x by minus 2. So if and only if minus 3 minus 6 minus 3a squared divided by minus 2 minus a is equal to minus 6a. Alright, so what do we want to do? We just want to solve for all values of a, satisfying this equation here. If a satisfies this equation here, then minus 3 minus 2 will satisfy the equation of the tangent line to y equal to f of x at this particular value of a. Alright, so now all we're doing is trying to solve this thing for a. Okay, so we'll simplify this a bit. In our numerator we have minus 3 minus 6, which is minus 9, and minus 3a squared is plus 3a squared. And I'm going to multiply both sides by this denominator, minus 2 minus a, and it will disappear on the left, and I'll have minus 6a times minus 2 minus a, and that will equal, first of all, minus 6a times minus 2, which is plus 12a. And then minus 6a minus a, which is plus 6a squared. When is this true? Well, let's take everything over to the right-hand side, and we'll have 0 on the left. We'll have 6a squared minus 3a squared, which is 3a squared. Still, we have this 12a, ugly plus. Okay. And then this minus 9 we've taken over to the right, we have plus 9. So we're just trying to solve for a when this particular quadratic in a takes the value 0. First thing we notice is maybe that we can factor out a 3. So let's do that. So this is true when 0 is equal to 3 times a squared plus 4a plus 3. And this we can further factor as 3 times a plus 1 times a plus 3, And so we're solving for when 3 times a plus 1 times a plus 3 is 0. It's going to be true exactly when one of these two factors is 0, which is to say when a is minus 1 or a is minus 3. So this is going to be true when a is equal to minus 1 or when a is equal to minus 3. Okay, so when a is minus 1 or a is minus 3, then we know that minus 2 minus 3 is going to lie on L sub a. All right, so going up again, back to our picture. Up here, when does minus 2, 3, when does this point lie on the tangent line to y equal to f of x at x equal to a? Well, when a is equal to minus 1, that looks about right. And I guess also when a is equal to minus 3. So a equal to minus 3 out here is out here. The corresponding point on the graph would be somewhere down here, I guess. And you could imagine the tangent line passing through minus 2, minus 3 as well. Okay, so there are two L sub a's, two tangent lines to y equal to f of x at x equal to a, passing through minus 2, minus 3. What are they? They are the tangent lines to y equals f of x when a is minus 1 and a is minus 3. And if we go up to the top, you'll notice that we're actually supposed to find the actual equations of these tangent lines L sub a that pass through minus 2, minus 3. So we should actually write down the equations of the tangent lines to our function y equal to f of x. We should write down the actual equations then to L sub a when a is minus 1 and minus 3. That's not going to be hard. In fact, we wrote down a general form for the tangent line to y equal to f of x at x equal to a. Here it is. Define the equation of L sub a then when a is minus 1 and minus 3. I'll just replace the a in this equation here by first minus 1 and then minus 3. Okay, so I'm going to call this equation up here star, and I'll just say from star as we go down. Okay, so from star, maybe I should write a sentence here first. Just gotta, pardon me. So, as I've just been saying, okay, so I'm gonna write that here. Hence, minus 2, minus 3 lies on the tangent lines L sub minus 1 and L sub minus 3 to y equal to f of x. So that's what we determined, and now I want to write down the equations of these lines, and I can say from star, here are the equations. From star above, which was actually red, so maybe you want it to be red again. From star up above, you can take a look, scroll back if you want. From star, we have L sub minus 1. Write that down first. So what do? We're just going to go up. All right, we'll go up. Here it is. From star, to find L sub minus 1, I'm just going to replace the A here by minus 1. So let's write down what we would get. Okay, and you can write it down yourself. You probably have it right in front of you because I'm sure you're taking notes or maybe doing it yourself. L sub minus 1 is y minus 6 minus 3 times minus 1 all squared, so replacing that a by minus 1, divided by x minus 1 equal to minus 6 times minus 1. And this, if we simplify it, looks like y minus, I've got 6 minus 3 in brackets, which is 3, equal to, I've got x plus 1 in the denominator, multiplying by 6. So we'll have 6x, in fact, plus 6. And simplifying this further, we can write this as y equal to 6x plus 9. And you might check to see that the point minus 2 minus 3 really lies on this line. If x is minus 2, I'll get 6 times minus 2 is minus 12 plus 9 is y equal to minus 3. All right, the second equation is L sub minus 3. This time replacing the a in equation star up above by minus 3. And we'll have y minus 6 minus 3 times minus 3 all squared. So divided by x minus 3 is equal to minus 6 times minus 3. And simplifying this, what will we get? We'll have y minus, so what do we have? 3 times 9 here is 27. 6 minus 27 is minus 21, and we have a minus minus, so I think that's y plus 21 is equal to 18x plus 18 times 3, which is 54. So we have y is 18x, subtracting 21, plus 33. Again, you can double check to make sure that minus 2, minus 2 minus 3 actually lies on this equation, and it does. All right, so that's it. We found the equations of the two tangent lines to the graph of y equal to f of x passing through the point minus 2, minus 3. Remember, that we weren't asked to find the equation of a tangent line to the actual curve because minus 2, minus 3 didn't lie on the curve. I kind of like this sort of question. I really quite like this sort of question. It's a challenging sort of question, but I like it. Something to keep in mind.